Welcome to Naradar Academy. In this video, we are going to discuss about construction of analytic functions. So for that, first we need to know what is a harmonic function and what is a harmonic conjugate. Okay, so let's start with harmonic function. A function of xy which has continuous partial derivatives of first two orders, okay, and satisfy the Laplace equation dou square u by dou x square plus dou square u by dou y square equal to 0 is called a harmonic function. Okay, so this is the condition to be satisfied for being a harmonic function, right? The first two derivatives, partial derivatives exist and this equation must be satisfied. Okay, then let's see some important results about harmonic function. If we have an analytic function f of z equal to u plus iv, then its real and imaginary parts u and v are both harmonic functions. Okay, and this v is called harmonic conjugate of u and u is called harmonic conjugate of minus v. Okay, then any two harmonic conjugates of a given harmonic function u in a region D differ only by a real constant. That is, suppose if you have a harmonic function u, then you can find its harmonic conjugates. No, you can find two or more harmonic conjugates for this function, but all the harmonic conjugates will differ only by means of a real constant. Okay, that is the difference between harmonic conjugates of a given harmonic function. Okay, next let's see what is the Laplace equation in polar coordinates. In Cartesian coordinates, it is dou square u by dou x square plus dou square u by dou y square equal to 0. In polar coordinates, it will take the form dou square u by dou r square plus 1 by r into dou u by dou r plus 1 by r square into dou square u by dou theta square equal to 0. So this is the Laplace equation in terms of r and theta. Okay, right. Suppose if u and v are two harmonic functions satisfying CR equations, then f of z equal to u plus iv is analytic in D. Okay, right? See, already we have seen a statement. The real and imaginary parts of an analytic function are harmonic. This is just like its converse. Okay, if I have two harmonic functions u and v and together with this harmonic function, what should we have? Satisfying CR equations. Then what can we say? F of z equal to u plus iv is an analytic function. Right. Next one is, if u is a harmonic function in a region D, then the function f of z equal to dou u by dou x minus I into dou u by dou y is also analytic in D. Okay, right. Now let's see some problems based on harmonic function. Check whether the following functions are harmonic or not. The first function is u of xy equal to x square minus y square. So if a function is given to you, what you have to check? Find out its first order and second order partial derivative with respect to x and y. Okay, now dou u by dou x equal to what? 2x, and dou u by dou y will be minus 2y. And dou square u by dou x square is 2 and dou square u by dou y square is minus 2. So if you add these two, what will you get? Dou square u by dou x square plus dou square u by dou y square equal to 2 minus 2 simply 0. So Laplace equation is satisfied. This equation is called what? Laplace equation. This is satisfied. Hence what we conclude? U is a harmonic function. Okay. Then next function u of xy equal to x square plus y. We have to check whether this is harmonic or not. Now u equal to x square plus y implies dou u by dou x equal to 2x and second derivative dou square u by dou x square is simply 2. Dou u by dou y is 1 and dou square u by dou y square is 0. So if you add the second order derivatives, what will you get? 2 plus 0, it's equal to 2, which is a non-zero value. Therefore, u is not a harmonic function. Okay. Next example, u of xy equal to log of root x square plus y square. Now we have to find its derivatives and you have to check whether this is harmonic or not. See, we can proceed. This is in terms of x and y, whether we can proceed with x and y, but I am going to do it by using r and theta because it will be easy for me to differentiate this function. That is, instead of doing this problem with x and y, I am going to replace it with r and theta. U is log root of x square plus y square, isn't it? But what is this root of x square plus y square? Modulus of u, isn't it? Modulus is, that is modulus of, not u, modulus of the complex number z, that is r. So I am taking this as log r. Okay, so my u is log r. What is dou u by dou r? 1 by r. And dou square u by dou r square is minus 1 by r square. What about theta? No theta term here. So dou u by dou theta is 0 and dou square u by dou theta square is also equal to 0. Since I have changed the problem into polar coordinates, I have to consider the Laplace equation like this. Dou square u by dou r square plus 1 by r dou u by dou r plus 1 by r square dou square u by dou theta square. Now substitute the values. What is dou square u by dou r square? Minus 1 by r square plus 1 by r into dou u by dou r is 1 by r. So 1 by r into 1 by r will be 1 by r square. And this value, that is differentiation with respect to theta, is 0. So what I have? Minus 1 by r square plus 1 by r square equal to 0. Therefore, u is harmonic. So in whatever coordinate system you are comfortable with, you can proceed. Okay. No need to stick on to the given question as it is. Okay, right. Then next problem. Show that u equal to y cube minus 3x square y is harmonic and find its harmonic conjugate. So once if you prove this function is harmonic, there will be a harmonic conjugate for this. Okay, we have to find it also. Now first let us check whether this is harmonic or not. So u equal to y cube minus 3x square y. That means dou u by dou x is minus 6xy, isn't it? And dou square u by dou x square is minus 6y. What is dou u by dou y? 3y square minus 3x square, and dou square u by dou y square is 6y, isn't it? Now add these two values. What will you get? Minus 6y plus 6y will be equal to 0, right? Therefore u is a harmonic function. Okay, so after proving it is a harmonic function, we are going to find out its harmonic conjugate. What is its harmonic conjugate? V. Okay, right. So if u and v are analytic function, okay, then what will you, if u and v are harmonic function, then what will we have? F of z equal to u plus iv is analytic, isn't it? Right. And one more condition has to be satisfied. What is that? Along with harmonic function, it has to satisfy what? CR equation. So here we assume u and v are harmonic function which satisfy CR equation. So hence what we have? F of z equal to u plus iv is analytic. Okay. Now write. What are the CR equations? Ux equal to vy and uy equal to minus vx. Okay. Therefore, vy equal to, what is ux value? Ux equal to minus 6xy, no? So vy equal to minus 6xy and minus vx is equal to uy. What is uy? 3y square minus 3x square. So vx equal to 3x square minus 3x square. So what I am doing here is I have to find v, no? For finding the value of v, I am making use of the CR equations. Okay. Using CR equations, I know the values of vy and vx. With these values, I am going to find what is the value of v. Okay, now you take any one of these two. So let me take this one. Okay, you can take any one of them. Let me take this one. This is partial derivative with respect to y, isn't it? So integrate this with respect to y. Okay, this is vy. If you integrate this with respect to y, what will you get? Simply v. So v equal to minus 6x into integrating with respect to y, no? So this y will become what? Y square by 2 plus whenever you are integrating with respect to y, this x is treated as a constant. So you will have a constant function g of x. Okay, right. Now this v, this is my v. Okay, that is what is the minus 3xy square plus g of x. This is my v and this is the harmonic conjugate of u. But here I have some unknown function of x, no? This g of x I have to find out. Okay, then only I can complete the problem. So for finding this unknown function g of x, what I am going to do is I am going to find vx and equate it to this vx. Already I have vx here, no? Now I am going to find vx from this expression and equate it to this vx. Okay, so that I can obtain the value of g of x. Now let's see. What is our v? Minus 3xy square plus g of x. So Vx means what? Differentiation with respect to x. So it will be minus 3y square plus g dash of x. But what is Vx from our CR equation? 3x square minus 3y square. So equate these two Vx. What will you get? 3x square minus 3y square equal to minus 3y square plus g dash of x. So this minus 3y square get cancelled. Simply we get g dash of x is equal to 3x square. So if you integrate this expression with respect to x, you will get g. So integrate with respect to x. What will you get? G of x is equal to 3x cube by 3 plus constant c. This is simply integrating constant. Okay. So g of x is equal to x cube plus c. Now substitute this value of g of x in this expression. So v equal to what? Minus 3xy square plus x cube plus c. So this is the harmonic conjugate of our u. Okay. Right. Then next problem. This is also the same type of problem. This problem already we have discussed. Check whether u equal to log root of x square plus y square is harmonic. If harmonic, find its harmonic conjugate. Okay, this problem I have discussed in the previous page. Okay, so I am not going to check whether it is harmonic or not here because already I have done there, no. So I am going to skip that part. So this problem I have already proceeded in terms of polar coordinates. So here also I am going to take in that way. So u equal to log r. So what is u r? 1 by r. And what is u theta? 0. Already I have proved it is a harmonic function. So now I am going to find only its harmonic conjugate. Okay. So v is the harmonic conjugate. U plus iv is analytic, no. So it satisfies CR equations. So what is the CR equation in polar form? UR equal to 1 by R into V theta and VR equal to minus 1 by R into U theta. Isn't it? Okay. So now substitute the value of UR. UR is what? 1 by R into V theta. Isn't it? Equal to 1 by R. This is 1 by R, no? So this 1 by R get cancelled. So what I get? V theta equal to simply 1. If I integrate this expression with respect to theta, I will get the value of V. So integrate with respect to theta. So V equal to 1 will become theta plus, while integrating with respect to theta, R is kept as a constant. So plus I have to put G of R, where G of R is a constant function. Okay, now let us come to the other part. What is VR? VR equal to, by CR equation, VR equal to minus 1 by R U theta. But U theta here is 0, no? So VR is also equal to 0. Now this is my V and this is my harmonic conjugate of U. But the only thing is I have to find what is the value of this G of R. For finding this G of R, I am going to find VR and then equate with this VR. Now differentiate with respect to R. So VR equal to, this theta will become what? 0 plus G dash of R. Equate with this value. So G dash of R equal to 0, or integrating this, what will you get? G of R equal to 0 plus constant C. Integrating constant C. So G of R is simply C. So what is your V? V equal to theta plus C. Okay. But originally the problem is given in terms of Cartesian coordinates, no? So you have to write the final answer in terms of Cartesian coordinates. Okay, what is theta? If z equal to x plus iy is the given complex number, then modulus of z is r and it is equal to root of x square plus y square. With this only we have started the problem, and theta is tan inverse of y by x, isn't it? So instead of this theta, I am replacing tan inverse of y by x plus c. Okay, right. Then next problem, show that v equal to cos hx cos y is harmonic and find its harmonic conjugate. Okay, here the v is given, that is the imaginary part. So if v is given, what is its harmonic conjugate? Minus u. Okay, first let me prove it is harmonic. For that I have to find its second order derivatives. So Vx equal to what? Sin hx cos y, and Vy equal to minus cos hx sin y. And Vxx is cos hx cos y, and Vyy is minus cos hx cos y. Right? Now if you add these two things, you will get 0. Therefore what we conclude? V is harmonic. Okay, next one. So if u and v are harmonic and satisfy CR equation, then f of z equal to u plus iv is analytic function. Okay, since it satisfies CR equation, what we have? Ux equal to vy and uy equal to minus vx. Okay, right. Now uy equal to minus vx implies uy equal to minus sin hx cos y and ux equal to minus cos hx sin y. So from this what I get, u equal to, that is integrating with respect to x, what you get, minus sin hx sin y plus g of y. Alright. Now this is my u, but I have to find this g of y. For finding this g of y, I am differentiating with respect to y. So uy equal to minus sin hx cos y plus g dash of y. Equate this with this uy. Okay, when you equate these two things, what will you get? G dash of y equal to 0. Therefore, g of y is equal to what? Constant. Therefore, u equal to minus sin hx sin y plus c. But what is the harmonic conjugate of v? Minus u. So don't forget this step, because in the option you may be given with minus sin hx sin y and plus sin hx sin y. Okay, you have to choose it correctly. For v, the harmonic conjugate is what? Minus u, not plus u. So the harmonic conjugate is what? Sin hx sin y minus c. Whether this may be plus c or minus c, that doesn't matter, because it is constant only, no? That is not bothered, but this sign has to be changed. Okay, right. Then next we are going to see construction of analytic function whose real or imaginary part, any one of them is given. Okay, for this we are going to use Milne-Johnson method. Okay, let me tell you, if that is for construction of analytic function, any one of the either real part or imaginary part will be given to you. You have to find what is the concerned analytic function. That can be done by using the previous method. Okay, that is, if u is given, we used to find v, no, it's harmonic conjugate. Similarly, if v is given, we used to find what is u. From that we can write what is f of z. F of z equal to u plus iv. Okay, in that way also you can proceed, but that will take a longer time. But when you use this Milne-Johnson method, you can directly arrive at the function. Okay, instead of finding the real and imaginary parts, you can directly arrive at the function f of z. So the choice is yours. If you want to find what are the real and imaginary parts separately, you can proceed with the previous way. Otherwise, if you don't want the real and imaginary parts separately, if you want to directly get the function f of z, you proceed by Milne-Johnson method. This is somehow simpler than the previous method. See, there is a formula for finding the analytic function f of z. If u is given, real part is given, then f of z equal to integral phi 1 of z comma 0 minus I into phi 2 of z comma 0 into dz plus c. What is this phi 1 and phi 2? Phi 1 is ux and phi 2 is uy. Okay, that is the derivative. First order derivatives, no? Ux is taken to be phi 1 and uy is taken to be phi 2. In that one, ux, you replace x by z and y by 0. That's all. Okay, replace x by z and y by 0. That will give you phi 1. And in uy, the same thing. Replace x by z and y by 0. That will give you phi 2. Then the formula is integral phi 1 minus I phi 2 into dz plus c. Okay, we'll see some examples. Find analytic function f of z equal to u plus iv whose real part is e power x into x cos y minus y sin y. So the real part is given. Okay. Now let me find ux and uy. What is ux? Differentiation with respect to x. So e power x into, here this is product, no? Product of two functions. So I'm going to make use of uv method, that is u into differentiation of v plus v into differentiation of u. So e power x into differentiation of this term. So x into cos y, no, so it will be simply cos y, this will be 0. So e power x into cos y plus, next one is, keep this term as it is, x cos y minus y sin y into differentiation of e power x is e power x. Okay, this is my ux. Don't simplify. Okay, let us substitute phi 1 of z comma 0, that is for x is for x you put z and for y you put is 0. So phi 1 of z comma 0 is equal to ux of z comma 0 equal to e power z into cos 0 plus e power z into z cos 0 minus 0. Okay, cos 0 is 1. So e power z plus here it will be what? Z e power z. This is my phi 1. Next, for finding phi 2, you have to find uy. Uy equal to, here no product rule is required. So e power x into, this will be what? Minus x sin y. Here again product rule you have to apply. So minus y into differentiation of sin y is cos y minus sin y into differentiation of y is 1. Okay, don't simplify, directly you substitute x equal to z and y equal to 0. So phi 2 of z comma 0 equal to e power z minus z into sine 0 minus 0 minus 0. So it is simply 0 because all these things are 0, no? Okay. What is f of z? F of z equal to integral phi 1 minus I phi 2 dz plus c. What is phi 1? E power z plus z e power z dz plus c. So e power z you take outside, it will be what? 1 plus z into dz. So by integration by parts, I am going to integrate this function. So for that you take this is as u 1 plus z and this as dv. E power z equal to what? E power z is dv. So du equal to dz and v equal to e power z. What is the formula for u dv? Integral u dv equal to uv minus integral v du. Okay, so uv, so 1 plus z into e power z minus integral v du, e power z into dz. So 1 plus z into e power z minus this will be simply what? E power z. So finally what I get? Z e power z plus c. So this is the required analytic function. Okay, so in this problem what we have done, with the given real part, I find out what is the analytic function. Okay, right. Then next problem. If f of z equal to u plus iv is an analytic function where u minus v equal to e power x into cos y minus sin y. Find f of z. Okay, instead of real part they have given what? U minus v. Here we have to find f of z. In the same way we are going to proceed. Now differentiate the given expression with respect to x and y. So what will you get? Ux minus vx and uy minus vy. Okay, right. Now what I am going to do is I am going to change everything in terms of u, because Milne-Thomson method only I am going to use here. For using Milne-Johnson method, I need ux and uy only. So I want to remove this vx and vy. So for that what I am doing is make use of CR equation. Okay, minus vx is uy. So you can simply write ux plus uy equal to this expression. And uy minus vy is nothing but ux. So uy minus ux equal to, that is what I have written here. Okay, that is what you are doing. Differentiate the given expression with respect to x and y. Keep it in your mind. I need only ux and uy. I want to remove this vx and vy. For that I am making use of CR equation. So minus vx is replaced by uy and vy is replaced by ux. Okay, so then I have written the expression. Now you add these two expression. If you add these two expression, you will get uy, and if you subtract these two expression, you will get ux. That is what I have proceed. Okay, so add these two equation. Ux get cancelled, no? So 2uy equal to, okay, e power x cos y. Here minus e power x cos y get cancelled. So what I have? Minus 2 e power x sin y. Therefore uy equal to minus e power x sin y. Milne-Johnson method only I am using, no? So uy has to be taken as phi 2 of z comma 0. So you substitute x equal to z and y equal to 0. So this phi 2 will become 0. Next, for getting ux, you have to subtract these two expressions. While subtracting, this uy get cancelled. So ux plus ux will become 2ux is equal to 2 e power x cos y. Okay, so ux equal to e power x cos y, and this is my phi 1. Phi 1 of z0 equal to e power z into cos 0 equal to what? E power z. Okay, right. Now substitute in the formula. F of z equal to integral phi 1 minus I phi 2 into dz plus c. So integral e power z dz plus c. So it's simply e power z plus c. Okay, that's all. See, here for Milne-Johnson method, I have discussed the problems with only with the real parts. If suppose imaginary part is given, what should you do? V is given means, then what you have to do is, see, I will take the previous problem. Suppose instead of real part, if they have given you the imaginary part, this will be taken as v, no? From that you find the first order derivatives vx and vy. Use CR equation. Vx is equal to what? Minus uy, no? So you take this as minus uy. Okay, minus uy means that will give you phi 2. Okay, and then here you will be having vy, no? Vy is equal to what? Ux. Ux means what? It is phi 1. Okay, using the phi 1 and phi 2 we can find. Okay, so I hope you understand this video. Thank you.